الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hi, everybody, and thank you for joining us, and welcome to the 2020 TensorFlow Everywhere event. So my name is Laurence Moroney. I lead AI advocacy here at Google, and I'm all the way up in the Pacific Northwest of the United States in a city called Seattle, where it's all snowy right now. So I'm really cold, so hopefully we can warm ourselves up with some good talk about AI and TensorFlow. So we're running these events, TensorFlow Everywhere, around the world over the next few weeks, and really sorry we can't be there in person to meet with you, but we're hoping that these virtual events can make things more accessible than ever before. In the last year or so, since we last had a TensorFlow-oriented summit called the TFDS, the world has changed a lot, and the global community has come together virtually, but a lot has happened. There's been a global pandemic, there's been fights for racial justice in various countries around the world. Many of us are experiencing changing personal circumstances, and we're all probably experiencing a very different way of working. So in times of uncertainty like this, we tend to turn to technology, and one new technology, machine learning, we turn to help. And we personally at Google have found comfort in knowing that we're part of an important infrastructure for the world that has the ability to be helpful for others. So for example, within Google ourselves, we've seen how TensorFlow has played a role in supporting Google Meet, which is our video conferencing software. And we've seen it being used as an education platform, as you can see here in the bottom middle photo. And we've also seen that it's helping software adapt to changing bandwidth to enhance picture quality. So often, if bandwidth conditions are constrained, then instead of having dropouts, we have this adaptive streaming so that the quality will change instead of you having a dropout, that kind of thing. We've actually seen daily usage of Meet grow by 30x since March, and we host about 3 billion minutes of video meetings daily. And we do have a blog post about this, and we can share that with you later. So with TensorFlow itself, what's happened is we've seen like this massive scale and growth. So it crossed over 100 million downloads. It's actually reached over 200 million downloads. And during the summer of 2020, in June alone, there were 10 million downloads. We have guides and tutorials on TensorFlow.org, and last year they had 45 million views. Our blog on the TensorFlow blog has had more than 8 million articles read, and our YouTube channel is approaching actually 10 million views of videos. We teach learners on Coursera and Udacity and other massively online open courses, and we've had over 800,000 learners of them. So we see the community is growing, and it's growing hugely. But what's all the fuss about? So what actually is TensorFlow, and what's it really for? And as for you as a developer, or for you wanting to adopt it, what is involved in TensorFlow? So we'd like to kind of describe TensorFlow as like an ecosystem of tools like this. They're on the left side of the diagram here, you can see there are training tools, and these are tools that you can use for creating models, all the way from creating a very simple model using something like Keras. And later, I'm going to be doing a talk called Zero to Hero, where I show how to do computer vision models using Keras, but also being able to scale that up to industrial size with distribution, something called distribution strategy, so you can train across multiple devices, CPUs, GPUs, TPUs, and multiple instances of each. There's toolings for understanding your models and how they work, because if you're not very familiar with machine learning, you end up training what's effectively a big black box full of parameters, and those parameters will act on data and give you a prediction off of that data. And sometimes it's good to have explainability to see what's going on inside of that black box. Then on the right-hand side of the diagram are the places where you can run your models. TensorFlow Serving, if you want a cloud on premises. TensorFlow Lite if you want to run it on devices, TensorFlow JS to allow you to do inference and even training in the browser. And then we also have other language bindings. Most commonly, you'll use Python when creating machine learning models, but we also have C, Java, Go, C#, stuff like that. So we've had an ecosystem that's really committed to the family of TensorFlow 2. We've been growing TensorFlow 2 over the last couple of years. We first released TensorFlow 2.0 with a big change to make it more Pythonic. So it has eager execution by default and tight integration with Keras. And then over time, it has evolved with 2.1 to add TPU support, 2.2 to have performance improvements, 2.3 to add things such as experimental TF data as a service, and then things called pre-processing layers in Keras to make the task of building models simpler. If you've ever built models, I always like to say it's like you've got this much code defining the model, but you've got this much code defining the pre-processing, managing your data, sorting out your data. And for example, for things like natural language processing. And the idea is if we can bring a lot of this code and minimize that and make that as part of the model architecture, then we can make your life a lot easier as a programmer. And so that's like experimental Keras pre-processing to handle those kind of things were added in 2.3. But then we recently released 2.4, and I want to spend a little bit of time on this one just to talk about where it's going and what we've been doing. So one of the big things that we've been leaning into is really distributed training. It's all very nice to be able to train on your developer workstation, and maybe you have a GPU on your developer workstation. But we've found with the industry growing towards ever larger and more sophisticated models that distributed training is necessary, where one GPU isn't enough. You might want to train on 50 GPUs or more, and then you want an API that's able to distribute the training across all of those effectively. So we've been working hard on that with multi-worker mirrored strategy, parameter server training, and stuff like that in TensorFlow 2.4. If you're familiar with NVIDIA, NVIDIA have GPUs, and they have drivers called CUDA and CUDNN8. And one of the things that's been a challenge has been evolving TensorFlow to stay in line with NVIDIA's releases of CUDA and CUDNN. So if you've been a TensorFlow developer and you've been using NVIDIA GPUs, you're probably using CUDA 9 or CUDA 10. One of the things that we did with TensorFlow 2.4 was to bring it up to date with CUDA 11. If you like NumPy, and data scientists, NumPy is like their right hand, you know, we've been adding support for a subset of NumPy APIs directly within TensorFlow called TF Experimental NumPy, and they're worth playing with. And as lots of other things, major refactors of Keras, we want to improve reliability, stability, and performance. And then going back to distributed training, there's the concept of mirrored variables. When you distribute training across a number of CPUs, sometimes they need to keep variables together and to be able to synchronize them with each other. And performance of that can be a bottleneck. So we've been working on performance improvements of those mirrored variables. So our ecosystem, we really want to tell the story. We want to design it that it's really from going from research to production to allowing you to deploy your models everywhere while being responsible with our AI. So starting with research, you know, we want to talk about, we really care deeply about researchers, and we want to make sure that the cutting edge work where you're pushing the envelope of what AI can do is supported with TensorFlow. And a few examples here of some models that we worked on, and there's links to the papers here, where things such as, for example, using PoseNet, not just to determine the skeleton of a person to see her pose, but also to be able to do real-time sign language detection from that. So we could actually have somebody do sign language in front of a camera and then have that translated in real time into text. And then, of course, you could use machine translation, for example, to translate that text into other languages. And then RL and being able to scale RL, reinforcement learning, is one of the things that's always been a challenge to be able to do quickly. So we've done some research around this thing called seed RL architecture and published this using TensorFlow, and you can see the link is here. And then one of the things that really excites me that's I think is going to be a huge field in years to come, although it's very nascent now, is really understanding quantum computing and being able to see how quantum computing can be used for machine learning. And we've been continuing to push the envelope forward there on how TensorFlow can be used for machine learning on quantum computers. And there's an example here of a paper with learning on quantum variational circuits. So this has led to a number of add-ons and a number of extensions that we have in TensorFlow for the TensorFlow ecosystem, where work from researchers has been able to be productized so that you can actually end up using it yourself. So there's a number of add-ons here. The one that you see, the graphic of the person rotating, I find is really exciting, and that's TF graphics, so that you can start to understand three-dimensional scenes. Like I said, later on, I'll be doing a talk on Zero to Hero for computer vision, but that's on flat images. And now with TF graphics and some of the work that's been done in research there, to start actually mapping an environment in 3 dimensions and being able to see something in 3 dimensions, I think it's going to be really, really exciting and have great real-world applications like self-driving cars, for example. So some of the research work we've also seen in models that we're migrating them to TensorFlow 2.x to make them easier for you to use. We released the object detection API recently, and the idea behind the object detection API is that object detection can be very, very hard to do and very hard to train models to be able to do it. For you to create your own object detection models, you'll typically have to do transfer learning. It's hard to do these from scratch. So we've released a whole bunch of stuff in the object detection API to make it easier for you to tag your images and to do transfer learning so that you can detect and tag objects like the image that you can see here, where there's about 8 people on a beach and there's like a number of kites. And in this case, it's able to see them. We also just recently announced TFRS, which is TensorFlow Recommenders, which again is research-oriented stuff to help you build recommender-based systems. And those are things like if you've done online shopping where it's seen your previous habits, that you tend to buy these kind of things, then you might be interested in this type of project, that type of work. That's what TF Recommenders is all about. And here again is the recommender system that I just mentioned. You can find it at this URL, tensorflow.org/recommenders. So next is in the ecosystem is really moving towards production. So we want to make it easier for you to be able to bring your models and take them to production. And one thing that we've heard from people is that to be able to go from local debugging, so building a simple model, trying it out simply locally, and then push it to the cloud to do training on the cloud so that you can take advantage of cloud scalability for training. But instead of you moving notebooks around and moving your code around, we wanted a simple API for that. And that's what we have here. It's a TensorFlow Cloud. It's a simple Python package. And if you're familiar with machine learning at all, you've probably seen this model before, which is just the MNIST model. But if we wanted to train this not on our machine, but wanted to move it to the cloud, it's that single line of code at the bottom where we see tfc.run, Docker image bucket name equals GCP bucket, and it will do the training then on Google Cloud for you. We're still working on it. It's not going to work for every model every time, but it's something that we find particularly exciting as a very, very easy way to offload your training to the cloud if you want to use cloud scale for your training. TPUs, as I mentioned beforehand, if you're not familiar with TPUs, the idea behind training a model is that if you train a model on a CPU is a general purpose chip that's designed to do anything. It's not optimized in any way for training. A GPU, which was typically invented for gaming, by some cosmic coincidence, is a wonderful device for training machine learning models. Because in gaming, 2 of the big things that you do are matrix multiplication and floating point operations. And those are 2 of the biggest things that happen when you're training a model. And as a result, GPUs have been very, very powerful for training models. But one thing that we noticed in our research was that if you reduce the precision in the mathematics from floating point 32-bit floating point operations to 8-bit integer operations, often the accuracy that you would lose is very little. And as a result, you'd be using 4 times less memory. You can do things much more quickly. And these things called TPUs were created, where the idea is that this is fully optimized on training. The T stands for tensor. So instead of like GPUs or CPUs, it's tensor processing units. And you can train much faster with these. A bit of a compromise to your code to be able to get there, but you can train super fast on TPUs. And with TensorFlow, we've been leaning heavily into that. So next comes deployment. And where can you run your models? So the one that I'm probably most excited about, and we're working very hard on in particular this year, is TensorFlow Lite. And the idea behind TensorFlow Lite is that instead of having a supercomputer to run the inference for your models, people use devices like phones and tablets and laptops, and more commonly now embedded systems. So the idea is, can we shrink models to run on those, and can we give an optimized runtime for them? And the answer to that is yes. And that's what gives us TensorFlow Lite. And the nice thing about that as well, of course, lower latency because the model's in the palm of your hand, and it can also preserve privacy. So for example, you might want to take a picture of something and have that classified, but you don't want to pass that picture to a cloud service where it passes through a number of servers in between you and the cloud service, not to mention the cloud service itself, to get an inference and get it back. Wouldn't it be really nice if all of that processing was done locally? And that's the idea behind TensorFlow Lite. We've also been working on TensorFlow JS, and the idea behind TensorFlow JS is so that the browser's JavaScript runtime can be used for doing inference on models and can also be used for training models. And so we've been looking at training and deploying models to the browser. We're working really hard on this to improve it all the time. We have a YouTube show called Made with TensorFlow JS, where people show off the kind of cool things that they do using TensorFlow JS. If you want a bit of fun, take a look at the Mona Lisa effect video here. And an urban legend has it that the statue or the painting of the Mona Lisa, as you walk around, its eyes follow you. This person built a model so that it looks at the webcam, and based on your location in the webcam, maybe you're to the left or to the right of the image, and the eyes will actually follow you. It's really cool, but slightly creepy. But like fun models that people have been able to build like this, I find really exciting. So there's some examples that we have here of things that we've done with our own technology using TensorFlow Lite on devices. One of the cool ones you can see here is OCR translation in Google Translate, where you can point the camera at a piece of text, it'll OCR that text, and then it'll translate it. Pre-pandemic, I used to travel a lot, and this thing was absolutely invaluable to me. So we've been making a lot of improvements to TensorFlow Lite. So in 4 columns, really: conversion, performance, model optimization, and the high-level APIs. I want to focus really on conversion, because when you train a model for TensorFlow, and that model is designed for running on a supercomputer. It's designed for running on something like with a GPU or those kind of things. When you want to get that model onto a smaller device, there's so many things that you have to take into account that you wouldn't take into account when it's running on a high-end computer, such as battery life. And so the idea with the conversion is to really shrink the model, battery optimize it, and make it, reducing the binary size as well, so you're like not impacting the size of somebody's app, and to really focus heavily on an improved and a better mobile experience. So when it comes, and a lot of that comes from model conversion. When you train your big model, you convert it to your light model. And then of course the third column here is model optimization, to think about how you're going to shrink the model to make it as efficient as possible. And things such as, if you're familiar with natural language processing, there's a pretty complex model type called an LSTM. And how do we shrink them? How do we make them more efficient to work on mobile? So we've been doing all of these improvements, and we continue to drive in that space. And then beyond all of these, going from research to production and deploying everywhere, we have to really think about responsible AI. We want to make sure that biases aren't introduced in AI, that the AI isn't misused, and that we don't rely too much on an AI system that might be poorly trained and stuff like that. And the best way for us to achieve this is through tooling. So with responsible AI, and some of the things that are like best practices that we want to publish, fairness tools, so we want to give you fairness indicators so that you can see that there might be biases in your data. Interpretability, so that you can actually see what the model is doing and why it's coming up with some of the predictions that it comes up with. Privacy, as I mentioned earlier on, for example, being able to run models locally, or to have technology that if models aren't run locally, that privacy can be maintained. And then of course the security. We want to make sure that your models are secure, that people aren't able to reverse engineer them, and those kind of things. So there was a pipeline when it comes to an ML workflow, and we think responsible AI can really be incorporated across this entire pipeline. So when you think about the pipeline, you're defining your problem, you're constructing, preparing, cleaning your data, then you're designing, building, and training the model, then you're deploying, and then you iterate through all of these. And there are so many places here where responsible AI can be ensured. So I'm going to focus on 2 of these at the moment. One of them is like when you're constructing and preparing your data, to be able to understand, is there actually real world or human bias in your data? If the data is only collected from one place, for example, then you can have an obvious bias towards the type of people who live in that place, or the conditions within that place. And then the second one I'd say is like when you're building and training your model, are the test users diverse? Are you getting fair and adequate training across, testing across all of the scenarios where your model can be used? And all of these questions are things that we want you to ask, we're asking, and we're providing guidelines for where you'll be able to ask these questions and the tools that we're going to give you to be able to analyze your data and analyze your model through all of these scenarios so that you can make sure that fairness is, it's part of your DNA as you're building, deploying, and iterating across all of your models. All right, so a few other things just want to talk about. There are TF privacy. So there's new functionality that we've added to TF privacy that allows you to assess your model's privacy. So training with privacy isn't always possible. So the new model functionality really is designed to allow you to measure the model's privacy without you actually having to retrain your model, sorry. So it's, to just inspect your model and to see if there's any potential privacy leaks in your model, those kind of things. Part of TF privacy. It's pretty new, we're still working on it, but it's something that kind of cool to check out. Another one of my favorites is this model card toolkit. And the idea behind this one is it can automate transparency reporting for your models. So model cards are a framework for sharing the essential facts of a machine learning model, and it's designed to be structured and accessible. So building a model card like this can be very time intensive. It does require specific expertise. So what we want to do is give you this toolkit to facilitate it by auto-generating some of the key components using existing pipeline artifacts and kind of display them in a standardized UI like this one. So for example, if you look at the example that I'm showing here is that there's a training set and there's an evaluation set on this training piece of data. And we notice when we look at the training sets that the attributes of people that we're talking about here, when you look at gender, that there are less than half of the women than there are of men. So if you look at the upper right here. And so we're getting this visualization right away, and we can see, if I'm training on something like this, I'm clearly biasing towards men. Or also, if we're looking at race, here, for example, I know probably the text is a little blurred, sorry, but it reads from top to bottom as other, American Indians or Eskimos, Asian or Pacific Islanders, Black, and then white. And we can see that the vast majority of people in this data set are white, and hardly any Asian, American Indian, Eskimos, or other race, and then just a few Black. So as a result, there's a clearly an implicit bias presented in the data, and the model cards are showing that to us so we can start thinking about how we can amend our data. And we see the pattern repeated into the evaluation set as well. So these kind of things we hope will help you be able to understand your data at the very beginning of your pipeline so that you're not training a model with data that has implicit biases within it. So these tools are available. It's on tensorflow.org/resources/responsible.ai. Go download them, have a play with them, and see what you can come up with. And then finally, we're going from research, production, deployed everywhere, empowering responsible AI. But the most important thing is really being powered by the community. And we love the community. We want to, I personally believe that AI can really change the world. Machine learning can change the world. But if it's only Google doing it, and if it's only the big companies doing it, then it's not really going to have the type of change that is potential. But if there's a community out there who are people who are equipped, who understand machine learning, who are building real solutions with machine learning and with AI, that's when the change will really happen. And that's also when the bubble of hype around AI will burst, and we'll be able to see the realistic kind of things where we can drive the world forward together using AI. So as a result, I'm particularly passionate about the community, and we want to make sure that the TensorFlow ecosystem is powered by the community. So some tools, for example, tensorboard.dev is, we wanted to get that out there to empower the community to be able to understand each other's models. So if you're not familiar with TensorBoard, sorry, TensorFlow board is a visualization tool, so you can understand your models, you can look at the internals of your models, so you can see how they trained, you can debug them. And tensorboard.dev, the idea is that to make it easier for you to share your model with other people so that they can see what's going on, instead of you just getting the binary blob of a model and putting it on a drive or somebody would download it or something along those lines. With tensorboard.dev, the idea is so you can really share these with each other, you can share your results and maybe help each other out, debug your models, those kind of things. As we can see here, like here's an example of where somebody was actually able to share on Twitter, that they were doing some training and they were able to share the results of their training on Twitter with a link to tensorboard.dev. And from that link, other people could go and see their model and see what was going on within it. I find it's pretty cool. We're also, to empower the community, we're working on translating and localizing as much of our data as possible. So TensorBoard, sorry, not our data, sorry, our resources, so our documentation, our samples, all of those kind of things. So the community has been translating our Jupyter notebooks, and we currently have 13 languages supported, and guides, tutorials, other documentation has been translated very heavily in Asia with the Japanese, Korean, and Chinese markets, but there are more to come. We're working heavily on that. There's been so much going on with user groups. It's really exciting. There's a few examples here of different meetups. In Tokyo, they like to look at neural network papers and have a meetup where they read them together and figure them out. The TensorFlow JS show and tell, they did one in Australia and last summer, which was a lot of fun, where a bunch of folks in the Australian community were able to get together and show and tell the kind of things that they do. In Turkey, as you can see at the bottom right, there was a series of online events called ML in the Wild, which I find particularly fun. And there's just so much going on in the community. And we want to really help if we help the community helps the world, and the world helps us, is how I like to look at it. And so there's lots of great stuff going on there. With TensorFlow user groups, there are a number of them around the world. Maybe you were introduced to this event today through a TensorFlow user group, and we're continuing to grow these, and we're continuing to support these. And if you're interested in creating one, there's an email address here at tfughelp@tensorflow.org. There's also special interest groups. There's many of them. You'll find them on tensorflow.org for various parts of TensorFlow, maybe input, output, networking, Swift, TensorBoard, whatever. You can see a list of them here. There are Google developer experts. There's 165 of these globally. And the Google developer experts, we love our GDEs, and we want to help other people grow into GDEs so that you can present that you are an expert in this field to help you in your career, as well as helping to grow the community. And so we also, one of the things that I'm personally involved in that I'm really passionate about is helping people in ML find jobs and helping employers find good ML people. And part of that has been to launch this certificate in TensorFlow development. So the basic ML programming concepts, also the ones that are most commonly looked for by employers, we found were computer vision, natural language processing with text classification, and sequences and prediction. So we've put together educational material on these in a number of different places, as well as an exam that tests these. And when somebody takes the exam and passes it, they receive the certificate in TensorFlow development. And we've stories from all over the world of people doing this and improving their careers as a result. So that's it for this talk. I'm going to be going online in a few minutes to do the Zero to Hero talk in a moment on another link. But Noor, I believe we have time for a couple of questions. Are there any questions on the live chat, or will I just go straight to the next session? I'll just go straight to the next session. So hold there for a moment. It's 9:28 a.m. here in Seattle. The next session will be beginning in 2 minutes at 9:30. And then maybe I can take some questions on the YouTube chat afterwards. I'll see you in just a minute.